In this lesson, we are going to look at and solve problems involving the area of parallelograms and triangles. We've already worked with these two figures, or these two shapes, throughout the year, but now we are going to apply more of the concepts that we've learned since then to being able to find the perimeter and to find the area of these two figures. The area of a parallelogram is the same as the area of a rectangle. So we are going to use both the base, which is this distance, and the height, which is this distance. Now we have to be really careful about that we make sure that this height is the altitude, okay? Which means that it makes that 90-degree angle with the base. Okay, and this figure could be turned on its side. So as long as you have a 90-degree angle, then you can have your height and your base. A lot of people make the mistake and use this distance right here. I'm just going to call it X as the height, but you'll see here that this angle is not 90 degrees, so we can't use that angle. So we're using the base and the height that are 90 degrees to each other, okay? So in this problem, we're going to find the perimeter, and we remember, and we should recall, that the perimeter is that distance around a figure. So what would be the distance that I walked if I started at R, walked to S, down to T, over to U, and back up to R? That's what I'm trying to find when I talk about the perimeter. So in this problem, I'm given the distance between R and S. I'm given this slanted distance between U and R. We know, or we should recall, that a parallelogram is a quadrilateral that have opposite sides that are both congruent and parallel. Okay, so RS is congruent to UT, it's also parallel to UT, and that RU is congruent to ST, and it's also parallel to ST. So we're calling that from previous lessons. So if we want to find the perimeter of this figure, we're just walking around it. It's all those segment length RS plus ST plus UT plus UR. And that will equal our total perimeter, okay? So RS is 32, ST, because it is opposite the side of RU, is also 20. TU, because it's opposite the side of RS, is 32. Now I picked this problem because this value right here, you don't need. It's part of that length, UT, which you know is 32. Plus UR, which is 20. And when we add all those together, we get the perimeter of the figure. So the perimeter of this figure is 104 inches. It's not inches squared because perimeter is a linear length, so it's just that linear measure. Now again, I want to reiterate that I picked this problem because we have this 12 inches right here that might throw you off. You don't add that in there because you already have that distance RS, which is the opposite side to UT, so we know those two sides are congruent and parallel. Now let's use the same figure to find the area of the figure. So here's the same parallelogram, and now we're going to find the area. We know that the area of a parallelogram is equal to the base length multiplied by the height length. And we have to remember that that base and that height make that 90-degree angle. So in this picture here, that 20, which is your RU length, is not your height because it's not a 90-degree angle. So we need to find this value right here, okay, which is our height. So it looks like we don't have it, okay? But we can find it. So we know that RU is 20. So what's the length of ST? Well, we discussed that in the last example, that it's also 20 inches. So now I can look at this triangle right here, and I'm going to pull it out so we can see it. Okay. This is S, this is T. I know that this right here is a right angle. If this side is a right angle, then this side is a right angle. I have a value 12 inches. I have the slanted inches, which is 20. And then because this is a right triangle, I can use the Pythagorean theorem to help me find this height. I have two lengths of a right triangle. I can find the third. So we'll start this problem by doing the Pythagorean theorem. We should recall that that is a squared plus b squared is equal to c squared. So my a is, and remember the a and the b, it doesn't matter which one it is. The height is my b, if I've used a 12 already, and my c, because it's across from the right angle, is my hypotenuse, so that's the 20. So pause the video and complete the Pythagorean theorem. You should be able to do this on your own. If you can't, you can go back to the Pythagorean theorem chapter and review that content. I've gotten to a point here where I have h squared is equal to 256. So now I need to continue to solve for h. So whenever I have a square, I can use a square root to get rid of it. I end up with h is equal to, and the square root of 256, okay, is actually 16. So my height is 16. Now I'm not finished the problem because I need to find an area. However, I just want to pause here for a second and talk about always double check what you want, because sometimes you want the exact value, okay, or the exact answer. So if you want the exact answer and you're being asked it, and this number inside of here, inside the square root, is not a perfect square, then you will have to simplify that radical. So you have to double check the form that you want your answer in. So if you want the exact value, you can't have a decimal approximation. So that would be like, I can't take the square root of 12. Okay, that's going to give me a decimal approximation. So when I simplify that radical, that would be 2 square roots of 3. Okay, so that's an example of a simplified radical. Now, that's not this problem. I'm just cautioning you to say some problems you may need to use that. Okay, so back to our problem. We can find our area. So area is equal to, we have the base, okay? Even though up here it's 32 and it looks like down here we don't have a value, we know that opposite sides of a parallelogram are congruent. So that's 32 is my base. My height is 16. I just calculated that. So then I'm just multiplying those together, and I'm getting that the area of my parallelogram is 512 inches squared, because it's an area. So there's the area of my parallelogram. Let's do one more example with a parallelogram. I want to find the area. So again, I know that the formula for a parallelogram is base times height. So here we have a base. So the base is this, and our height is that distance that is perpendicular, so that 90-degree angles to the base. So we have our base, which is 12. But we have to find our height, okay? So in this problem, we are given that this side right here is 9. We know that opposite sides of a parallelogram are congruent. So then if QR is 9, then PS is also 9. I'm given this 45-degree angle right here, okay? So really what I have, I'm gonna pull it out. so that we can see it, is that I'm pulling out this triangle. This is 45, this is 9, and I'm looking for my height, and I have a right angle. So we have two options here. We know that this is, if it's this right here is a 45-degree angle, then this must be a 45, 45, 90 triangle. So we can use our properties of special right triangles to solve this, or we could use trig, okay? Now, if this is not a 45, 45, 90, or a 30, 60, 90, then we would have to use trig. So you'll get and you would get a decimal approximation on here. I'm going to solve the problem both ways. I think it just depends on whether or not you're being asked for an exact answer versus a decimal approximation. So again, you have to be sure of what you're being asked for your final answer. So if I'm going to use 45, 45, 90, then I know that this is 1 square root of 2. So then I can set up my proportion. So 9 to the square root of 2 is the same thing as h is to 1. And then I can just do my cross multiplication. So I'm going to end up with h is equal to 9 over the square root of 2. Well, we don't like that square root of 2 in the denominator, so we have to simplify that radical. And I get h is equal to 9 square root of 2 over 2. Okay, so there's one way. Or I could use trig. So if I use trig, so this is not a and, this is an or, trig. So I'm going to resketch that triangle. So I just resketched that triangle, and now I have some things I can label. Well, the 9 is across from the right angle, so that is my hypotenuse. The 45 is the 45 is right here, so the h is across from that, so that's my opposite. So I have the opposite and the hypotenuse, so I can use the sine function. Sine is opposite hypotenuse. So the sine of 45 is equal to h over 9. And just be careful that this h stands for the height, not the hypotenuse. So my sine function is opposite over hypotenuse. So difference between that lower h and that uppercase h. So then I can just multiply both sides by 9. So I get 9 sine of 45. So 9 sine of 45 is equal to h. So this is the height of my triangle. And the decimal approximation for that is, we need to put that in our calculator. So make sure your calculator is in degree mode. Just double check yourself. It's been a while since we've done that. So 9 sine of 45 is equal to 6.3639. So 364. So just be sure and see if you're being asked for the exact. You're going to have to use the 45, 45, 90. If you're not, and you can round to the nearest thousandth, then you can use trig. Okay, so now let's put those values in here. So I'm going to use the special right triangle one first. So my height is 9 square root of 2 over 2. And I can combine those things. So really what I have here is 12 times 9, which is 108, times the square root of 2, all divided by 2. I can still simplify that because that 108 can be divided by 2. And I get 54 square root of 2. And then my units, I don't have units on this question. So that would just be units squared, or if I had feet or inches or whatever, that's what it is, okay? So this right here is my exact answer. So just make sure that you know which form you're being asked in, Or if I use the trig value, that's going to be 12 times. And I'm actually just going to go back and use that trig value here, because I don't like to round mid-problem, and it's the same thing. So on my calculator again, I can do 9 times sine of 45. I'm going to hit enter, and then I'm going to do times 12, and I get 76. Oops, that's not a 6. 76.3675. So the 7 would round up to an 8 units squared. And this would be the approximate answer, because I have a decimal approximation that I've rounded. Now, if I put 54 times the square root of 2 in my calculator, I should get the same answer, and I do. So just to reiterate, this problem could be solved in either way, with the properties of special right triangles or with trig, just being sure you know which form you're being asked for your final answer in.